I've been asked to do a little bit of help with number 6 on 5.3, which is on page 364. And it's a lot like example 1, but they just kind of upped the intensity level a little bit. So what I've chosen to do is I'm going to look at D and F because those ones are a little bit more complex, and hopefully you'll be able to do the rest of them given these examples. So let's get started. Now, this one, I'm supposed to figure out what x is, and I can't do that unless my bases are the same. I can't change 2 into 4, but I can change 4 into 2, because 4 is 2 squared. So that's where I'm going to start. Rewrite this as 2 squared to the power of x minus 1 equal to 2 to the power of x plus 3. I know that my exponent rules tell me that if I have an exponent inside a set of brackets raised to an exponent outside a set of brackets, that I multiply these. And I can see that my bases are the same. If the bases are the same, that means that this is literally 2 raised to the this power equals 2 raised to the this power, which means the powers must be the same if they're equal. I can disregard the bases. So I'm just going to write 2 times x minus 1, because that's what I'm focusing on is right here and right here. These guys are gone. Equals x plus 3. Remembering that if I have something outside a set of brackets, I have to multiply it by everything inside the set of brackets. That's going to give me 2x minus 2 equals x plus 3. Now to solve for the variable, I need the variable on one side and the numbers on the other side. So I'm going to bring this x across, and I'm going to send this 2 over that way. This is a positive x, so it's going to come across as a negative. This is a negative 2, so it's going to come across as a positive. That gives me 2x minus x on this side equal to 3 plus 2 on that side. 2x minus x just gives me, this is like 1x, right? So it gives me 1x equals 5. Now if I wanted to, I could go back up to this equation and I could plug in the 5 and see if I'm correct. So 4 to the power of 5 minus 1 should be 2 to the power of 5 plus 3. 5 minus 1 is 4. 5 plus 3 is 8. If I use my calculator to figure out what those numbers are, it makes sense that they're going to be the same even if I don't know the total number, because every 4 has 2 2's in it. So if I have 8 2's, it should be the same as 4 4's. But you could just use your calculator, go 4 to the power of 4, 2 to the power of 8, and you'll see that the number is the same. It's 256, I think. Doesn't matter. So the idea here is that I make the bases the same, so I can get rid of the bases and just focus on the exponents. And then I rearrange the equation here to solve for the variable, and I'm done. So let's try it on this other one. Now I've got kind of a funky one where it says 9 to the power of whatever equals 243 to the power of whatever. You could try to see if 9 is perfectly able to be raised to a power to get to 243, or you could just recognize that 9, and your book does this all the time, it uses the same numbers over and over again. 9 is 3 squared, which means that 243 is probably 3 to the power of something. So we'll play with that. So 3 squared to the power of x plus 1 equals, and I could use my calculator and just guess and check. I don't love guess and check, but like I said, your book uses the same numbers quite often, so you'll learn the numbers that they're using. 729 comes up a lot. It's super fancy, but you'll see that the patterns are there. They like to use 2's, 3's, 5's, and 7's as bases. So we go to 3 to the power of, I don't know, 5. Let's try that one. Oh, look, 3 to the power of 5 is 243. So I can write 3 to the power of 5, x plus 3. Get rid of this calculator. And now, again, I can say my bases are the same, so what I want to focus on is my exponents. Get rid of those guys. 2 times x plus 1 equals 5 times x plus 3. Multiply through here, 2x plus 2 equals 5x plus 15. Again, I don't like negatives, so I'm going to move the small x over to the side that the big X is on. And so my 2x is going that way as a negative 2x, and my 15's coming this way as a negative 15. So, and you could have done it the other way, it doesn't matter. It works out the same in the end. I'll have negative 15 plus 2 equals, so I got those guys, 5x minus 2x. So I move my x's over here, move my numbers over here, it's beautiful. Negative 15 plus 2 is negative 13. 5x minus 2x is 3x. This one's a little bit funky because it doesn't give us perfect numbers, but that's okay. I need to move my 3 away from the x, so it's multiplied on this side. I'm going to divide on this side, which gets rid of it. So x is negative 13 over 3. If I wanted to, I could probably turn that into a decimal and plug it into the original formula and see if the numbers come out the same way that I did here. So just because it's negative 13 over 3 makes it a tiny bit more awkward to work with, but you could still check it using the same method.